So this is a continuation of the electromagnetic wave. So in this video, I will discuss to you about electromagnetic spectrum. So this is for grade 10 and this is for the second grading. So let's go to the page 2, just the usual. So this is the page 2. Then on next page, or page 3, we have the introductory message, so you can read this at your own time, at your own pace. So let's focus on the page number 4. So on page number 4, you're gonna write on your piece of paper, the yellow pad, of course, your name, your graded section, the date you answered this module, and then do not forget to put in the subject, which is science, and then you put also the module number or the MELC number. So it's science 10 and module 2 or week 2. So for the learning competency with the code, we're going to compare the relative wavelengths of the different forms of electromagnetic waves. So for the support competencies, we have number 1, identify the different regions of the electromagnetic spectrum. Number 2, calculate the wavelength, frequency, and energy of EM waves. And another number 2, this is just a typo error, but this one is number 3, so compare the relative wavelengths, frequencies, and energies of different regions of electromagnetic spectrum. For the background information for you guys, so light is a form of electromagnetic wave. Do you know of other forms of this wave? So we have James Clerk Maxwell. He is the proponent of the electromagnetic wave theory, stated that EM waves take several forms depending on their frequencies and wavelengths. The electromagnetic spectrum describes the different forms of light. So do you know that the light you see, which is made of colors of the rainbow, represents only a portion of the electromagnetic spectrum? Well, there are more to light than what meets the eye. In this lesson, you will learn more about different regions of the electromagnetic spectrum and compare the EM waves in terms of wavelengths, frequencies, and energies. So these are on the part 3 here, the accompanying the textbooks and educational sites. So these are the references that you might use to check some other details, but I'm gonna write other references on the descriptions below, or description below. You can just check it out. For the activity proper, activity 1, so we have the electromagnetic spectrum is a continuum of all the EM waves arranged according to frequency and wavelength. The entire range of the spectrum is broken into the specific regions. So these are radio waves, microwave, infrared, visible light, ultraviolet, we have X-ray, and the gamma ray. Actually, there's another one, the last one, which is the cosmic radiation, but it's not included here in your module, so it's okay. So you're going to read the textbook materials to understand more about electromagnetic spectrum. So EM waves can be described in terms of its wavelength, frequency, and energy. Wavelength is the distance measured from one crest to the next crest, or from one trough to another trough of a wave. It is denoted with the symbol lambda and is expressed in meters. Frequency is the number of waves that has a fixed point in each time. It is denoted by F and is expressed in hertz or cycles per second. Energy is the amount of photons that wave carries. It is denoted by E and expressed in joules. The energy of photon can be calculated using the equation. So this is the equation, which is E is equals to H times M. So H here, remember, H is the max Planck, or where H is the Planck's constant and F is the frequency of the EM wave. The value of the Planck's constant is 6.63 times 10 to the 34 joules per second. In other references, you might see that it's not 6.63, but rather it is 6.626. So it has 3 decimal places. It we have the 6.626, but in this module what we call it, more round off into the nearest hundred, so that's why it became 6.623 times 10 to the 34 joules per second. We have a simple problem here, so you're going to find the value of energy of a wave with a frequency of 5 Hz. But before we go over on this calculation, let me explain to you something about how to calculate the energy and something more about the electromagnetic spectrum. In this video, we're going to go over the electromagnetic spectrum. So we're going to go on order. The first one you need to know are radio waves. Radio waves have the lowest energy but the longest wavelength. After the radio waves, there are microwaves, and then it's infrared. After infrared, you have the visible light. So it's a spectrum. You have colors such as red, orange, yellow, green, blue, and violet. After violet, you have ultraviolet rays, and then you have X-rays, and then gamma rays. And then after gamma, you have cosmic radiation. What you need to know is that as you go to the right, the energy increases. So gamma rays have more energy than X-rays. As you go to the right, the frequency increases so ultraviolet light has a higher frequency than infrared. As you go to the left, the wavelength increases. So radio waves are the longer than microwaves. So here are some questions. Which photon has more energy, a blue photon or red photon? A photon is simply a particle of light, so that one that has more energy is the one that's on the right side. So if we compare a red photon to a blue photon, the blue photon's on the right side, so the blue photon has more energy. Now, which one has a higher frequency? Microwaves or infrared radiation? Frequency increases as we move to the right, so infrared radiation will have higher frequency. Now, which one has a longer wavelength? X-rays or gamma rays? So X-rays or gamma rays wavelength increases to the left, so X-rays has a longer wavelength. Alright, so let's try some questions. Which one has more energy? Microwaves or ultraviolet radiation? So energy increases to the right, it's going to be UV light or ultraviolet radiation. Now, which one has a lower frequency? Gamma rays or cosmic radiation. Frequency increases to the right, so the one with the lower frequency is going on the left or on the left side. And that's the gamma rays. Now, which one has a shorter wavelength? Yellow light or the green light? The wavelengths increase to the left, but they decrease to the right, so the shorter wavelength is going to be on the right side, and so that's green. A green photon is going to be shorter in wavelength than a yellow photon. Now, you need to know the relationship between wavelength, frequency, and energy. The wavelength is represented by the lambda or lambda. It's a symbol. As the wavelength increases, the frequency will decrease. And also the energy of the photon will decrease as well if the wavelength decreases. The frequency and the energy will increase, so a short wavelength corresponds to a high energy photon and a high frequency. A long wavelength corresponds to low frequency and low energy. So energy is equals to max constant value times to the frequency. So based on the equation, you can see that as the frequency increases, the wavelength increases. These two are directly related. So let's plug in Planck's constant, which is 6.6 to 6 times to the negative 34. Now we're going to put the units joules times seconds, and then we're going to multiply with the frequency of 4.2 and 6 times 10 to the 14 Hertz or run over seconds. So notice that the unit seconds cancel. So we're going to be left with the unit joules, which is the unit for energy. So if you multiply those two numbers, you should get around 2.84 times 10 to the negative 19 joules. So now you know how to calculate the energy of a photon. In this part, we're going to focus on multiplying two numbers in scientific notation. So let's start with this example. Let's say if we have 4 times 10 to the 4 and we wish to multiply by 2 times 10 to the 3. How can we do this? Now, the first thing we need to do is multiply the numbers. 4 times 2 is equals to 8. Next, we can focus on 10 to 4 times 10 to the 3. So when it's 10 to the 4 multiplied by 10 to the 3, well, since the bases are the same, we are allowed to add the exponent. So then this is equal to 10 raised to the 4 plus 3, which is 10 to the 7. So the answer is 8 times 10 to the 7, and that's a simple way in which you can multiply two numbers in scientific notation. Don't forget to add the exponents. Now let's try another example. Let's multiply 3 times 10 to the 5th by 2 times 10 to the 7th. So this is going to equal 3 times 2 multiplied by 10 raised to 5 plus 7. So 3 times 2 is 6. 5 plus 7 is 12. So the answer is 6 times 10 to the 12th. Now it's your turn. Feel free to pause the video and try this example. Multiply 3 times 10 to the 7 by 3 times 10 to the 8th. So let's start by multiplying 3 by 3, and then let's add the exponents. It's going to be 7 plus 8. So 3 times 3 is 9, 7 plus 8 is 15, and that's all you need to do. Now let's try some harder examples. Let's multiply 8 times 10 to the 5th by 7 times 10 to the 6th. So first we need to multiply 8 by 7, and just as before we need to add 6. 8 times 7 is 56, and 5 plus 6 is 11. So we have 56 times 10 to 11th. Now this number, it's not in proper scientific notations. We need this number to be more than 1 but less than 10. So therefore we need to move the decimal forearm here 1 unit to left. So if we move it 1 unit to the left, what's going to happen to the exponent? Will it decrease by 1 or increase by 1? So if we decrease the number 56 to 5.6, we need to increase the exponent such that the number remains the same. So anytime you move the decimal point to the left, the exponent should increase by 1 value. So this is going to be 5.6 times 10 to the 12. Let's try another example. So 9 times 10 to the 4 times 6 times 10 to the negative 7. Take a minute and try that example. So this is going to be 9 times 6 times 10 raised to the 4 minus 7, or you could say it's like 4 plus negative 7, which is the same as 4 minus 7. 9 times 6 is 54, and 4 minus 7 is negative 3. So let's move the decimal 1 unit to the left. So the exponent is gonna increase by 1. So this is gonna become 5.4 times 10 to the negative 2 now. If you are wondering why it becomes negative 2, it's because when you add positive 1 to negative 3, it will become negative 2. Now going back to the sample problem, so we're going to find the value of energy of a wave with a frequency of 5 Hz. So given that the max Planck's constant is 6.623 times 10 to the 34 joules, and frequency is 5 Hz or 5 per second, and then what we're looking for is the energy, because based on the problem, we're going to find the value of energy. So the missing part here is the energy. So going to the solution, we have E is equals to Planck's constant times frequency, which is the formula, our formula. So we're going to substitute. Planck's constant is 6.623 times 10 to the 34 joules per second times frequency, which is 5 seconds or 5 hertz or 5 cycles per second. And then the answer is 3.31 or 3.315 times 10 to 35 joules. Now for your practice, you're going to solve the following problems. So you're going to write in your paper activity number 1, and then below that you're going to copy the question, which is question number 1. What is the energy carried by a photon with a frequency of 1.0 times 10 to the 6 cycles per second? So you're going to show exactly the same as what you have seen here. So you're going to put in given. What are the given? So you're going to write it below, and then you're going to show the solution. For the number 2 question, the wavelength of green light from a traffic signal is centered at 5.20 times 10 to the negative 5 centimeter. So you're going to calculate frequency. So on the number 2, you're going to look for frequency. For the number 1, you're going to look for the energy. Now on the number 3, what is the wavelength of radio wave with a frequency of 1.5 times 10 to the 7 hertz? So on number 3, you're going to look for the wavelength. Okay. For the activity number 2, you're going to refer to page 148 of learner's module and study the diagram of the electromagnetic spectrum, then answer the following question. Now if you don't have this learner's module or the book that has this page 148, you may refer to the references that I have on the description below, so just check it out. For the question number 1, what are the different regions of the electromagnetic spectrum? So you're going to enumerate all the regions mentioned on the previous video. Number 2, which EM wave has the longest wavelength and which one has the shortest wavelength? Number 3, which EM wave has the highest frequency and which one has the lowest frequency? Number 4, what is the trend in the frequency when EM waves are arranged in order of increasing wavelength? So you're gonna write all the EM spectrum here in accordance to the increasing of the wavelength. And number 5, how are wavelength and frequency related? So you're going to describe the difference between wavelength and frequency on this number. Number 6, which wave carries the highest energy and which one carries the lowest energy? And for the last number, how are energy and frequency related? For the activity number 3, you're going to copy the question again, and you're going to arrange the electromagnetic waves found in the electromagnetic spectrum according to increasing wavelength and increasing frequency, decreasing energy, decreasing frequency, and increasing energy. So you're going to write the electromagnetic waves in according to the given question. For the reflection, you're going to complete the statement or the statements below. So you understand, you supply the answer, and then I don't understand, if there is any, and then I need more information about. Okay, so that's it. So I hope to see you again on my next video for the week 3 or the module 3. Thank you.